This is for the O-level way. And if you're IP students, you should know yours is the O-level or the A-level way. All right? I call it style. Not much of a explanation, so I need to have something for you to appreciate. Ready? Here we go. Now, in Haber process, what happens when you do something to the temperature of it? So, you can either increase or decrease the temperature. Let's say we decrease it, right? It can go anywhere, once again. If we decrease the temperature, it will increase the yield of ammonia. How do you know? O-level students, you don't have an answer. You got zero reasoning. So can I fake it out for you? Think of it this way. Your N2H2 become ammonia. Yes, a molecule, the product. If the temperature is very high, lots of energy, think of it this way. The energy will break the bonds. Make sense? And reverse back. That's how I memorize. It's really hardcore memorizing without understanding. Later, I'll teach you the understanding. The real one. All right? So again, this is how I think. To go very fast. You've got to have a way. Okay? So, if not, assuming you can have your way and remember this, so decreasing temperature increase the yield. So it's good to decrease the temperature, i.e. it's an advantage. Write this down. It's an advantage to decrease the temperature. However, it's a disadvantage when it comes to the rate. It's bad. Where are we? This one you know how to explain. Rate of reaction. When decreased temperature, kinetic energy is lower, blah, 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 blah. The rate decreases. All right? So you cannot keep decreasing the temperature. Right? Okay? Now, there are three things I want to share. It's actually behind. Now, remember, it's all about money. It's all about money. So you need to think like a businessman. To the businessman, you need to clear two things. You need to talk about the how fast, the rates. You also need to talk about what? You need to talk about how much you get per batch of product that come out. Think like a businessman, think like a business woman. They are not the same. This refers to how fast, once again, very easy one. You refers to how much. If you don't understand this, you might have to talk to your English teacher. Right? In primary school, sorry to say. How fast and how much are two different terms. Correct? Done. So always remember they are different. All right, next we're going to play the effect of pressure. If you increase the pressure, again you can decrease, then all the effect go the other way around. You increase the pressure, you will increase the yield, the how much you get. Again, you don't have the explanation in terms of yield, so I will fake it out. It's like, yeah, you make all the molecules close together, then I think high chance for them to bump together, and then, yeah, they're going to make ammonia a lot more. All right, more of them will connect together, right? Bond together. I think it's advantage. Yeah, that's how I think. Again, you high advantage. And you increase the pressure, wow. The rate also advantage. This one you can explain because more particles per unit volume increase the frequency of effective collision. Yes, blah, 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 increase the rate. Okay, then why not pressure we use, right now it's 1 ATM, we use 1000 ATM. 2000, 3000. Cannot. Oh, but right, you high, rate fast. Wow, damn profitable the business. Cannot. Because very dangerous when you have high pressure and high temperature. A lot of people, the answer stop here. Full stop, you get zero. Why? Ladies and gentlemen, humans in this era can handle danger. Human can fly to the moon and come back already. Realize? I'm waiting for China to have that mass production of going to the moon. Because China will always make it cheap first before they increase the price. Before I die, I hope I can go to the moon one round. All right? If I have enough money. Right now, US can do that for you. But you can afford go lah. Right? I can't. If I can afford, I want to go one round. All right? Hey, the day before you die, you can go to the moon and then come back. Wow, that's an achievement before you die. Oh, I want to do that. I'm waiting for China to do that. All right, maybe they got a train to go up and the train come down. Mass production stuff. Why not? All right, ladies and gentlemen, what I want to say is humans can handle danger. Everything that last time is like Star Trek, whatnot, didn't happen. It has all happened. AI has come in, you think for you. You just say, hey, help me think. They'll think for you. It's not, they can handle it. But the problem is what? is here, is the money. Going to the moon is not dangerous anymore. If you have the money, they'll make it safe for you. Ladies and gentlemen, remember, you must finish the statement. It is dangerous and therefore is costly because you need to have very expensive equipments. All right, or maintain the expensive equipments. That is the problem when you have too high a pressure. Okay, remember that, huh? Last but not least, TPC, right? Then we do what? We add catalyst. Rate of reaction. If you add suitable catalyst, it will increase the rate. So the rate is good. Advantage. However, but it has no effect on the U. We learn this again in catalyst where we're doing both energetics and rate of reaction, I believe. Done. All right. So all in all, the engineers, the chemists will run multiple billions, millions, billions of experiments. They found out this is the optimum condition for things to occur. All right. Temperature for Haber process is 450 degrees Celsius. Temperature of 250. Is it 200 or 250? 250. Okay, I want you to check because different schools use different value. All right, put this. I want you to go and use the one that's in your school. I don't want to argue because, okay, go and sort it out. Okay, everyone, I have my own value. Okay, 200 or 250, go and check. Use your school one. Yes? Huh? ATM. ATM, thank you. ATM. Okay, presence of a finely divided iron catalyst. It's risky iron, but I put finely divided because of rate reaction, right? So I play safe. Finely divided iron catalyst. Ladies and gentlemen, M for memorize 2 to 3 marks over here. All the best and good luck to you. These are all the baby things. And save you a lot of time. Now again, it's a reversible reaction, so the U won't be 100%. Technically, in the industry, it's only about 15%. I don't think we need to know the number, but we need to appreciate it never hit 100. Again, the ammonia gas is extracted by condensation, which is through cooling. And the unreacted N2 and H2, you recycle them back into the reaction chamber. And this is usually a U graph that's associated with Haber process or all industrial process, which it will be given and you can play with it. Okay, but I'm going to ask you a question. If this is not given, and then I ask you to draw a graph, you see how you reverse engineer and become a question, right? I give you this, I give you this, I give you this, and then I ask you to draw the graph. So this is not given. Can you draw? And I give you 3 marks. You should be able to draw. So you want to take a look at the graph first. Why? Because we have learned here already. We have memorized this. Make sense, everyone? Can? You know whether increase, decrease pressure and temperature, what happened to the U. So I repeat myself, you might be asked to draw this graph if it's not given. They ask you to have a simple sketch. Can you sketch it out? It looks like this. So it was based on the reasoning on top. All right, everyone, take an arrow and then tell yourself from here, the whole chunk there, come here. Okay? Can you sketch a graph out of it? Yes, congratulations. Done. Here we go, finish.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.